Sorry.
Good morning, everybody.
Good morning, Phil.
Little thing before I get started here with my presentation today. I want to emphasize to every one of you in here, Mr. Hamilton tells you all the time, stay busy on your work and study. If you don't, you will come to the point where you're having to cram 3 or 4 things in at one time. Do it now while you've got the opportunity. Don't wait till the last minute and try to do it all together.
Amen.
Okay? It would really benefit you if you'll listen. Okay, today I'm going to be talking about the OSI model. Can anyone tell me what the OSI model is or what it stands for? What OSI stands for? Open Systems Interconnect Reference Model. That's the key word in this. This is a reference only. Okay? It's give you some guidelines to follow through, especially when you're troubleshooting and doing different things with figuring out why a system won't operate properly. Okay? But this is something that you will use throughout your entire career. Okay? Now, like I said, the OSI model was, it came to be by the International Organizational Standardizations Organization, which is ISO. Okay? It's a theoretical representation of what happens between 2 modes of communication or 2 computers or what levels they work at. Okay, can anyone tell me the 7 layers of the OSI model? Anybody give me one of them?
Physical,
Yes.
hardware,
Hardware.
Physical, data link network, data link layer, I'm sorry, network layer, transport layer, the sessions layer, your presentation layer, and the application layer. Okay, there's a mnemonic way that your book gives you in order to remember these layers. It's all people seem to need data processing. Okay, they give from the way I've got it listed from the bottom to the top. If you look at the OSI model, you'll see it listed in both ways, bottom, top, top to bottom. As long as you know what it is and the steps that it goes through, it doesn't matter which way you can memorize it. Now, the little mnemonic that I use for me to be able to remember it is, please don't no one throw the sausage pizza away. It's good for breakfast tomorrow, next morning, or lunch, you know. It's easy for me to remember, so that's what I've used. Okay. Now, on the physical layer, can someone give me examples of the components of the physical layer?
network interface card.
Your cabling, your network interface cards, whether they be wireless or wired, all of this happens at the physical layer. Okay, the other thing is the synchronization or the electric signal that's sent across lines through these cards. Okay, just a little bit about protocols, because I'm going to be talking about protocols quite a bit through the rest of this. Does anyone know what a protocol is? Okay, put it in layman's terms, it's this. It's a set of rules that everyone agrees upon to do a particular task or how to handle a certain situation. Okay, so if you're talking to someone and you agree to speak to them in English, then you can understand each other. If one of you speak in English and the other one speaks in German, you cannot communicate across those links. You can't understand what they're saying. Okay, so the protocol is the basis of communications. Okay, now layer 2 is the data link layer, and it's the building blocks for the entire process. Even though we start at the physical layer, the data layer is the first layer where a lot of your links and your protocols start to happen and come into play. The data link protocol is the basic fundamental of addressing, which allows us to send information from one device to another. With this protocol, it doesn't matter if you're on the same network or a different network, it understands and knows how to talk to each other. In this layer, the data is broken down into frames or groups for delivery across different media systems. Different operating systems such as Ethernet carries packets at different sizes. This layer helps determine how the packet's broken down and encapsulated into the physical reference to be moved through the system. The data link layer is divided into two sublayers. Does anyone know what those two sublayers are? Okay, to begin with, we've got the logical link control layer. You have to remember this is logical. It's the mental links. A lot of this, what we're dealing with, is all going to be philosophical. You can't see it, touch it, smell it, but it's there and it's way it goes through the process. Your physical layer is the one that you can touch. Okay, the local link layer is responsible for error checking and packet synchronization to make sure that the receiving unit can process what is being sent to it. Also, we've got the media access control layer. Normally we think of this as just the MAC layer, and whenever we speak of MAC, we're thinking of the MAC address or the hardwired device address. Okay. MAC address is actually the media access control. It's the protocol that it goes through in order to go across these layers. Can anyone give me an example of what type of protocol would be in the data link layer? Or what protocols the data link layer might use?
TCP/IP?
No, a little further down on the line. That one's coming up. We're not there yet.
ARP?
Glenn? ARP. ARP is a good one. ARP, 802.11 wireless, that's another one. OpenFlow. Now we're moving on up to the network layer. And also in the data layer, there's point-to-point protocol also, used in tunneling for networking a lot. Now for the network layer, this is where we start to get into what we see all the time, okay? This is the internet protocol layer. Smack me. Which we know as the IP layer, okay? It's one of the protocols that we use, excuse me, to fragment the frames and to transfer different networks. Logical addressing is the first part of the network layer. Each node on the layer must have its own address or physical, for its physical network. This is where our terms of IPv4 and IPv6 come into play. Now, we know that IPv6, through our classes and understanding, we know that it's a 32-bit address that's subdivided into 4 octets with 8-bit groups and uses a dotted decimal system notation. Does anyone know how many addresses in IPv4 are available on the network? Remember?
IPv4?
Yes.
3? Is it like 6 billion or something?
4 million.
42 or something?
4.19 billion addresses. I'm sorry. Can't get my numbers straight this morning. Okay. With that being said, you're thinking 4 billion addresses. That's a lot of addresses. Actually, they're all gone today. They've done been used up. Okay. In 1998, they come out with the IPv6 version. The IPv6 is addressed as 128-bit with 8 groups of 4 hexadecimal digits separated by colons. Okay, the framework for the network packets are encapsulated in frames. They're given the headers and the trailers to create a PDU, or your protocol data unit, where our protocols come back into play. The layer 3 header contains the IP addressing for the packet, such as the source and destination of the information. Now, header has three parts to it itself. It has the start frame, which signals the device and says that I've got a message coming to you. It's got the address, which is your main data, which crossed the line, and the final portion of it is the type or the length of the frame, if the length and type are needed. The trailer has two parts to it. It's a FCS, or your frame check sequence, and the stop frame when the field is not used, when the field length is not used. The frame check sequence is an error correcting sequence. Okay, it's got a number that's sent into the packet so that whenever it gets to the other end, it says, okay, if these numbers match, then you've gotten all the information. If the numbers don't match, they'll send back a response, say, hey, I'm missing this, send me this packet. Okay, if the message is too large to go across the layer, as an example, Ethernet, does anyone know what size packet Ethernet can carry? Okay, it's 1,518 bytes. Okay, it's not very much. Whenever you add your headers and your trailers to everything, it breaks that down. Other topologies of networking runs at different levels. They have to have smaller bytes before they can be processed or whatever. This layer is responsible for handling and moving and breaking down those fragments into the different network frame sizes. Network layer is also responsible for error handling. ICPM is a protocol used at this layer, and it's a protocol that we use through a lot of our testing. Ping and traceroute go through ICMP. Now, if you're using ICMP, it must be enabled on your system. Okay? Normally those comes and they are disabled, so keep that in mind as you're going through. Okay, on our layer 3 network, other than the ones that I've done named, of IPv4, and IPv6, and IMCP, can anyone give me another example of protocol used at this layer? RIP is exactly right. That's Routing Information Protocol. Next, we move up to the transport layer. The transport layer provides the end communication within the architectural structure of the network. It provides services as reliability, flow control, and multiplexing. Reliability is making sure that the dentist's data is sent across the internet and is received in the same manner as which it was sent. Your flow control controls the amount of data transported between the two nodes so that if one is running at a faster speed than the other one, it doesn't overwhelm it. In other words, they communicate together to reach an agreement on the speed in which all devices can understand what's going on. Multiplexing allows applications to listen to their own ports. Every application has a certain port that it receives information and transmits the information across to be able to communicate with the other devices or with the other layers. Okay, the primary protocols for the transport layer are the TCP and UDP. Can anyone tell me what TCP is?
Transport control protocol.
Something we've all heard through our training and through our classes. The protocol is used in every web browser and email. TCP utilizes guaranteed delivery, and it's used when data is important to reach its client. It's when you want all the message out, you don't want to get half of it and then leave out the other half. In UDP, it's a connectionless protocol or a best effort. It's sort of like hollering out a statement and saying, okay, can anybody hear me? And if they do, fine, and if they don't, they don't hear anyway. I ain't gonna repeat myself 15 times till everybody does. You know, one time and move on. Layer 4 is also where, as I mentioned, we have port and destination port addresses. Okay, these are used a lot in your troubleshooting methods, especially whenever you get into networking. Telnet is one of the protocols that we use in Layer 4. Can anyone tell me what the port address to Telnet is? If you don't know it, I guarantee you will see it again on your A+ test. Believe me, I took my final one yesterday. Okay? You've got to know a lot of these port numbers. Telnet runs on port 23. Okay? Now, anybody tell me how many ports there are?
56,353.
You reversed your first numbers. You done that the other day.
60. Crap.
65,535.
How many of them will you have to know?
All
No, actually, you don't have to know all of them. But I am going to say this. There are a key of about 10 that you will see repetitively. If you see it more than one time in your lessons, I'll about guarantee you better know it. Okay? It will come back to you again. All right, that concludes our transport layer. Now we're going to move on up to the sessions layer. Sessions layer is responsible for establishing, maintaining, and terminating the connection. Okay, it's like using your home telephone. You don't pick it up, you dial the number, you reach the member on the other end, you sit there and talk to them. When you get done, you hang it up. Okay, that's everything that the session layer does. It establishes that connection and keeps it and maintains it while you're on it. And then whenever you're done with it, it disregards it. Okay? Another good example, we use it every day. We go in and sign into our computers, right? Get on the internet. We walk away from our computer. We come back to it, click on it, internet's still there. Well, your systems layer is what's caused that to happen. Okay? So, now, with that being said, there's 3 basic modes of transmission in the sessions layer. Anyone know what they are? Any guesses? Okay. We're going to start out with the simplex. That's the first one. That is a one-way communication. Okay. We got some parents in here. Some of you are not. Some of you will be. This is the way I like to think of simplex. Okay. For the ones that are parents like me, okay, ever been talking to your kids, trying to get a point across, but they keep trying to interrupt? Wait a minute, just be quiet a minute and let me talk. Whenever I get done, then you can talk. That's what your sessions layer does. It steps in and says, one way on. You listen to me, when I get done talking, then I'll listen to what you have to say. We do it every day. Half duplex is where transmission moves in both directions. That goes back to your phone line. One talks, the other one talks back. It's bi-directional. And then your full duplex is when transmission modules are moved in both directions simultaneously at the same time. Now, in order for full duplex to work, you've got to have a full duplex NIC card. Loop back and collision detection must be disabled or turned off on the NIC card to have full duplexing. And the drivers must support simultaneous transmission to receive the information in the data. Can anyone give me examples of protocols that run on the session layer? How about the PPTP?
Yeah, that's what I was saying.
Which is point-to-point tunneling protocols. Okay. For the Apple machines, you got ASP, which is Apple Top Sessions. and SMPP, which is short message peer-to-peer. Sorry about that. All right, now we've got to move on up to the presentation layer. Presentation layer has the presentation layer's main function is to act as a translator. It sets the packets to send to the other presentation layer in a level in which it can read and understand. Also in the presentation layer is encryption and decryption. As an example, when you log on to your bank account, okay, you're going across a secure website, HTTPS, okay? This layer is what allows it to be able to be decrypted so that you can understand what information has been sent. There's not a whole lot in the upper two layers. The final layer is the application layer. Now, this is the first part of it, after we left the physical layer, that you actually get to see anything. Okay? The application layer is just that. It's the applications that are running. Good example, whenever you pull up MSN or any other website. The application layer is the model that we can see. It's the picture that's there. The application layer only standardizes communications and depends on the underlying transport layer protocols to establish host connections and channel transfers and client-server and peer-to-peer network models. Can anyone give me an example of what you'll find at, or what protocol you'll find at the application layer? Because this is the largest layer with those protocols.
HTTP?
HTTP. HTTP also runs at the at the presentation layer. So it's, HTTP works at both layers. But it is one of the main ones we use at the application layer. A few of the others are secure SSH or secure shell, SAP, sessions announcement protocol, and TSP, timestamp protocols. Okay, all your web server devices also work on this layer. And that's going to do it for my presentation today. Does anyone have any questions that I could help them with? Yes.
On what layer does stuff like POP run on?
Okay. POP, I don't have them all memorized. And anybody that can memorize them, you're doing a whole lot better than I am. So I better go back through my notes here and find out what layer POP comes up to.
It's an email.
Yeah, but no.
I think it's the session layer.
Or SMTP. Yeah, so that's what I'm just saying.
Okay, just like networking, you don't know. Mr. Hamilton, would you help me with this, please? What layer does POP?
I'm going to ask you a question back.
Well, I'm trying to escalate it to a higher standard.
Does it have an application port address?
Yes.
Then what layer do those run at?
Port addresses run at layer, transport layer. All right. Sessions?
POP does use,
It uses certain ones from the transport layer.
it does use
because-
IP because it's connection oriented.
Okay.
But what application layer service does it use? 110. So it's got an application layer port.
Application layer. Sorry. Another thing, networking. We all don't know the answer. Sometimes you gotta have help. Don't be afraid to ask. That concludes it. Any more questions? I'm sorry. Thank you very much.